All right, so we got to find the derivatives of all of these, and it may not look like it, but all of these are power rule problems. So first off, recognize to use the power rule, it's got to be x to some power. So we have to rewrite all of these as x to some power. So this is, again, where our algebra 2 rules start coming into play. Because how do we do 2 over x? How do you rewrite that? Well, if you're dividing by x, that's a negative exponent. So this is 2 times x to the negative 1 if we rewrite that function. And something that's really important to keep track of here is we haven't taken the derivative yet, right? Sometimes we have to do a lot of work before we even take the derivative. So this is just rewriting the function. Now we can take the derivative. So we'll note that by saying y prime, this prime is like the derivative, it equals what? So how do we do this? Well, it's the same exact thing. We move the power to the front. So we'll say negative 1 times 2. Because, of course, those coefficients always stay there when you're taking derivatives. And then the power decreases by 1. So be careful. Make sure you're doing that the right way. Because it's like currently negative 1. And we're going to subtract 1 from that. So what are we actually getting when we decrease the power? We're getting x to the negative 2. Because negative 1 goes down by 1, negative 2. And then how do you rewrite this? Well, I mean, we're done, right? Negative 2 times x to the negative 2. Like, that's the derivative. But often it's nicer and people like you to write it so it kind of looks like how it did in the beginning. So, in other words, just get rid of the negative exponents. So it'd be kind of nicer to rewrite it as like negative 2 over x squared. And just notice, I mean, this is really important, that like this negative 2 exponent only goes to the x. It doesn't go to the negative 2 as well, so it stays in the top, right? Like we don't have this. We don't have the negative 2 going to everything. It's just going to the x. So the x goes to the bottom, but the negative 2 stays at the top. All right, so that felt like a whole problem, but that was just part A. So what do we do the next one? Well, the next one we don't even have to rewrite. See, it's already as just like the variable to some power, so we can just go ahead and do it. So when we find f prime of t, what are we going to do? Well, we're going to bring the power to the front. So I'll go ahead and write it out now. We're going to do the 2 times the 4 and decrease the power by 1. So 2 decreased by 1 becomes 1. And then it's still over 5. Because remember, basically, this 4/5, that coefficient, that just stays there. It just remains untouched. We just bring the 2 to the front, decrease the power by 1. So now we'll just simplify a little bit. Like 2 times 4, that's 8. T to the first, that's just t. So 8t over 5. There's our derivative. If you want to rewrite it too, there's no better way. But it is very important to know that we could bring that t to the outside if we wanted and make that like 8/5 t. People get really confused about that. But both of those are totally valid ways to write that. All right, what is next? So we need to rewrite this as some power as well. So we'll leave the 2 there, and then square root of x. How do you write the square root of x as x to some power? Well, we should know this. The square root is the 1/2 power, so that's x to the 1/2. Again, algebra 2 skills coming into handy. And then what do you now we take the derivative. We haven't even taken the derivative yet, but now we can take the derivative. So y prime is, well, it's the exact same thing. We're going to bring the power to the front. So we'll do 2 times 1/2 and then decrease the power by 1. So x, I'll write it out for now, to the 1/2 minus 1. And beautiful, that's our derivative. Let's make it look a little prettier. So 2 times 1/2, that's awesome. Those just cancel out. And then what's 1/2 minus 1? Well, we can find a common denominator, but we should know that 1/2 minus 1 is negative 1/2. So we got x to the negative 1/2. We can do a little better with that. It's a negative exponent, which means we got to put it in the denominator. We got to divide by it. And it's to the 1/2. So just like we did in the beginning, let's put that back as a square root. So square root of x. And that's our derivative. Beautiful. And see how it's nice that like we put it back in a square root. Like our original answer didn't have any like fraction exponents, didn't have any negative exponents, so our answer really shouldn't either. All right, last hard one. So we got to rewrite this as x to some power. Well, so first off, we got our coefficient here, and like all the numbers, that's just going to sit. That's just going to chill. So we'll just have the 1/2. And then we got to rewrite this as some power. So it's got everything here. So first off, it's in the denominator, which means it's going to be a negative power when we bring it to the top. And then it's a cube root. So that means it's 1/3, because that's how you write a cube root, just like square root is 1/2. But then it's x squared. So it's actually to the 2/3. So this is what we have, 1/2 x to the negative 2/3. And so now that we've done that, now we're ready to take the derivative. So we'll say that the derivative is, let's see, let's change colors, because this is getting a little cluttered here. So we'll say that y prime is, well, we'll bring the negative 2/3 to the front, so negative 2/3. But that's still multiplied by the 1/2. And then x to the negative 2/3 minus 1. So think about that, negative 5/3. And then now we just got to simplify. So how is this going to simplify? Well, first off, the 2's are going to cancel. And then look at what we got going on with the x's. So we'll just for now, negative 1/3. And then we'll go ahead and deal with this, as it's a negative. So let's go ahead and move it to the bottom. So x to the 5/3. But then what is x to the 5/3? Because isn't x to the 5/3 like we have x times x to the 2/3? Because that's like x to the first. And if you're multiplying those exponents, you're multiplying those bases, you would add the exponents. And 1 plus 2/3 is 5/3. So that's going to be the nice way to write that, because then we can get rid of the fractional exponent and rewrite that as negative 1/3 x times the cube root of x squared. And then that would be a good final answer, fully simplified final answer. And just to point out, if we would have kind of done that from here, so if we would have written this as negative 1/3 times the cube root of x to the 5th, well, then see what you can do there. This x to the 5th, that's x times x times x times x times x. So this group of 3 x's here, you could pull that out to the front. And so just the same, you would get the 3x, and then these 2 x's are left inside. So it's still the cube root of x squared. So see how either way you get that, it still works out. But I think seeing it like this is like cleaner in my mind, to like separate that up into its parts first instead of trying to simplify this cube root. But either way, that's some good stuff. That just follows with the gist of these. Like all of these you can use the power rule for. You can even use the power rule for more complicated ones, which will probably be what we do next. You just have to rewrite it first, and then it's just fine. All right, and then this last one's the easiest one, actually. Surprised I save it for last. Because what is this here? This is just the power rule still, right? Because this is x to the first. And it seems a little weirder, but it works exactly the same way. So when we try to do the derivative, we're going to bring the power to the front. The power is just 1, so we're going to bring the 1 to the front. That's still being multiplied by the negative 3/2. And then we decrease the power by 1. So x to the 1 minus 1. Okay, well now we simplify, so we get negative 3/2, because 1 times negative 3/2 is still negative 3/2. And then x to the 1 minus 1, so x to the 0. And what is x to the 0? But 1. So this is just negative 3/2 times 1, or just negative 3/2. The x just went away. And that actually makes sense when you realize that this is in mx plus b form, so the slope, which is what the derivative is, the slope, is just right there, negative 3/2. And you see that when we use the power rule, we just ended up getting that same thing. So it confirms that idea.